Now we're talking about hearing. So the ear is involved in hearing, but we also have a whole series of structures that help us maintain the position of the head and allow us to keep our head in a certain position, whether we're sitting or running. So all of these functions of equilibrium, that's part of this hearing and equilibrium system. So we want to be aware of as we're moving and the position of the skull and so on and our hearing. Okay, let's look at the overview of the ear. Okay, so external acoustic canal, tympanic membrane, the auditory ossicles, those ossicles. So this is the middle ear. This is to the auditory tube or the eustachian tube that allows us to maintain pressure so that there's not a sufficient change in temperature to blow out our eardrum. So the sound is funneled toward the eardrum. It vibrates. That vibrating information goes into the cochlea, and that's where hearing is processed. The semicircular canals, that's part of the equilibrium process. So here's the middle ear. Here's the eardrum. Here's the three bones, the malleus, the incus, and the stapes. The round window is where the pressure that is put in here is relieved. So the pressure moves throughout the cochlea, and that pressure will end its path after it's stimulated various portions of the cochlear membrane where the receptor cells for hearing are present. So here we have the cochlea, and that's where the receptors for hearing are. Then we have these other structures, the utricle, the saccule, and the semicircular canals. These are all involved in equilibrium and position, dynamic movement and static movement. So the eardrum is going to vibrate and send information into the cochlea. The other structures will constantly monitor the position of our head and the movements that are going on. The hair cells of the ear are going to be bent by the sound wave and the distortion or bending of these stereocilia. It's going to stimulate the hair cell. It can be inhibited or stimulated, and depending on where the cells are in the cochlea, you're going to detect various frequencies and intensity or loudness of the sound. The equilibrium, as I said, through the semicircular ducts, they're also going to have stereocilia that are going to move, and that's going to allow you to be aware of your head position and the position of your head as you're moving around. So the stereocilia are in a gelatinous mass. They're distorted by fluid movement and detects anterior, posterior motion in three planes, X, Y, and Z. So these other structures, the saccule and the utricle, are cells suspended in a jelly-like material, and there's also going to be otoliths, little rocks. And as your head moves, these substances right here, this is a gelatinous material in the cupula. these structures move depending on the movement in the cupola. So depending upon the direction of bending and direction of rotation, this endolimpin here is going to move, and you'll be able to sense, your body automatically senses your head position and its movement. So in the vestibule, you have this gelatinous material, and you have these otoliths, which are little crystals. And as your head rotates and moves, the movement of these otoliths in the gelatinous material and causing a different position in the receptors, that's going to allow us to constantly maintain the proper position and movement of our head. So depending upon the position of the head, when you move your head, these otoliths are going to move, and they're going to bend these hairs in a certain direction, and you'll be aware of your head position. Okay, let's look at hearing. So make sure you look at these slides, so on. So here's the outer ear, here's the middle ear. So sound will enter the cochlear duct right here, and that sound has different frequencies, and depending on where the part of the basal membrane where vibration occurs, so location, location, location. So where the sound waves cause vibration in the basal membrane and the intensity, that's how we're going to hear various frequencies and different intensity or loudness. So this is where the hearing receptors are located in the basal membrane. There are various fluids in there that convey the sound vibrations as movement of the fluids. And that's perilymph in the vestibular duct, and there's endolymph in the cochlear duct. So know that we have physical sound waves that cause vibration in the middle ear of the auditory bones, and then that is converted into waves within these fluids, and depending upon the frequency and intensity of these sound waves, different sections of the basal membrane are going to respond, and that's how we distinguish between intensity and frequency. The auditory pathways, let's look at those. Did we show that? Nope, we don't. Okay. So the cochlear nerve, cranial nerve 8 is going to have a cochlear branch, and it's have another branch going to the equilibrium apparatus. Okay, all done there. So let's go back to the here, turn recording off.